All right, so first things first, before we can talk about trig and how it affects right triangles, we first need to talk about similar right triangles. All right, now, way back in Unit 2, we talked about similar triangles. All right, so what's the difference between similar triangles and congruent triangles? Who remembers? True. So congruent triangles, they're equal to each other. But how we know they're equal to each other?
Congruent is like same size and shape, but similar to same shape.
Right. So congruent, same size, same shape. Similar is only same shape. All right. So that means what in terms of its sides and angles? The sides are proportional and the angles are congruent. All right. So remember, similar triangles, the sides are proportional, the angles are congruent. All right. So corresponding angles are congruent, corresponding sides are proportional. Now, similar right triangles have some fairly specific properties about them. All right, so let's look. So, first off, we need to justify that ABC must be similar to DEF. All right. Now, who remembers the postulates that you can use to figure out if you have similar triangles? So it's side angle side. What else? SSS, and there's one more. AA. Good. So those are the three postulates we can use to figure out if we have congruent triangles or not. Not congruent, similar, sorry. So which one would probably give us the least amount of work to do? So you could use SSS, but I'm thinking of one other one.
The right triangle.
Not AA. SAS. I would use SAS because we already know that one angle in both triangles is what? 90 degrees. So we already have a set of congruent angles right there. Now, the reason I say SAS would probably be easier than SSS is so you don't have to check 3 proportions. You only got to check 2. All right. So we need to check that 2 sides are proportionals. Which 2 sides do I need to check? We need to check the 4 and the 8 and the 3 and the 6. In other words, the ones around the right triangle. So it says that if you do the corresponding sides over each other. So we have 3 over 6. It should equal the other 2 corresponding sides, so 4 over 8. Is that true? Yep. Both are equal to 1/2. Thus, triangle ABC is similar to triangle DEF by SAS. All right, so we're 100% certain that those 2 triangles are similar. If we did do it by side, 5 over 10 is also 1/2, so it still works. All right. Now, they want us to find a couple of different ratios. Okay, so we're going to use these 2 triangles and we're going to find the ratios that they want us to find. So BC over AB, what would that be? 3 over 4. That's in simplest form, so we move on. BC over AC, what is that? 3 over 5. AB over AC. 4/5. EF over DE. 6/8, which simplifies to 3/4. EF over DF. 6/10, which simplifies down to what? 3/5. And then DE over DF, which simplifies down to. All right. Now, if you notice above, the ratios of relatively positioned sides within two similar triangles are equal. All right. Now, of course, this is always true regardless of whether it's a right triangle or any other type of triangle. All right. That's just true in terms of similar triangles. Now, in the diagram below, it says that triangle DEF is a dilation of ABC by a scale constant equal to K. So they want us to algebraically show that DE over EF is equal to AB over BC. Now, we talked about dilations way back in transformation, so that very first unit that we ever did. If DEF is a dilation of ABC by a scale factor of K, what does that mean? So in other words, let's say I called this X, Y, Z. What would be the side lengths of DE, EF, and DF? So KX, KY, and KZ. All you would do is just take K, multiply it to the three side lengths. All right. So if I want to show that DE is equal over EF is equal to AB over BC, algebraically, here's how I would do it. So first off, we would say that DE over EF is equal to KX over KY, and AB over BC is equal to X over Y. So why would they be equal to each other? Right, they're both multiplied by K, so what can I do if you have K over K? It cancels out, it becomes what? 1. So what happens is that Kx over Ky is equal to X over Y, because these cancel out, meaning you would get X over Y is equal to X over Y. All right, so that's how you would show that they're equal to each other. All right. Now, exercise 3. They said that MNP is similar to EFG, and they gave us a couple of side lengths. And they want us to know what is the ratio of EG to EF. So, first off, all right, let's just draw the triangles. So we have two different triangles. So this is M and P. No, this would be. And this would be E, F, G. Now, they said that MN is 10, NP is 6, MP is 14. Now, based off of our answer choices that they gave us, EFG would be a dilation of MNP by a scale factor of what? Right, it'd be 1/2. Another way you could have figured it out is EG to EF. If we wanted to find EG over EF, what's its corresponding sides? MP and MN. All right. So that should be the same thing as MP over MN. So MP is 14, MN is 10. So that would be 7 over 5. So that means this would be 7, 5. What do you think FG would be? 3. So it's 7/5. Now, why would it not be 5/7? Why do I know it's 7/5 and not 5/7? Because it's EG to EF. So whatever it says first, that's your numerator. All right, that's what they mean in ratios. All right. Now, we can use ratios of relatively positioned sides or ratios of corresponding sides to solve a variety of real-world problems. So, a person who is 68 inches tall casts a shadow that is 54 inches long. At the same moment, a tree standing vertically casts a shadow that is 18 feet long. And they want to know what is the height of the tree in feet. And they want us to round to the nearest foot. So if you're talking a geometry problem and they don't give you a picture, you need to draw one. All right. So we got us a random person here. All right. This person is 68 inches. Now, they cast a shadow. All right. So their shadow is right here. They cast that shadow, which is 54 inches. All right, we're assuming the shadow is directly on the ground. It's at a 90-degree angle. Now, at the same time, we got ourselves a tree. All right. This tree stands at, we don't know, so that's X. But we do know that it casts a shadow. So some shadow of the tree. Cast that shadow at 18 feet. Now, before we even start, what is the glaring issue? Feet and inches, all right? Different units, so we cannot do proportions yet until we do what? Conversion. All right, if I were you, just because 54 and 68 will not go nicely into 12, I would convert the 18 to inches. So you're not dealing with decimals. All right. So how would I figure out how many inches are in 18 feet? Multiply by 12. So how many inches are in 18 feet? 260 inches. 216, sorry. My ears are kind of stuffy right now, guys, so you gotta speak loud. All right, so how would I set my proportion? (68) over 54 is equal to, good. Now, we talked about this last week. All right. in terms of this is a rational function. All right, so how do we solve it? Cross multiply. So 54x is equal to what? What's 68 times 216? 14,600 and what? 88. So what's the only thing I got to do? Divide both sides by 54. So what's x equal to? 272 inches. Now, they said inches, but what they wanted in? Feet. So what's my last step that I got to do? Divide by 12. All right, so round it to the nearest foot, so to the nearest whole number. It's 23 feet, approximately. So, guys, even though you guys don't have an EOC for this class, just be careful with units and word problems because I can guarantee you, Math 3 EOC, they love throwing that kind of stuff at you. Yes, ma'am.
I didn't realize it was inches and feet at first, and I just solved it, and I still got 23.
That was lucky. It doesn't always work out that nicely. All right. Any questions on 4? All right, look at 5. A rectangular picture has a width of 4.5 inches and a height of 3 inches. The picture is scaled up to a size that the new width is 6 inches. After scaling the picture's new height, what is the length of its diagonal to the nearest tenth of an inch? All right. So, if I draw a rectangle, okay. So the width is 4.5, the height is 3. And yes, I know I did not draw that to scale, but it's okay. Now, they scaled it up so that the new width is 6 inches. All right. So that means that if you did 4.5 over 6, it should equal what? 0.75. All right. So in other words, 3/4. So they scaled it up by 4/3. All right. So if we want to know what the new height is, let's just call that x. 4.5 over 6 is equal to 6 over x. Oops, nope. 4.5 over 3. All right. So that's 4.5x is equal to 18. So x is equal to what? 4. All right. Now, that's all fine, Dave, but they want to know what the length of the diagonal is. Does anyone know what a diagonal is in a rectangle?
Split in half.
Yeah, so it's just from one vertex to the other that's diagonal from each other. All right. And since it's a rectangle, we know that angle is right. So how can I find what the other side is? Pythagorean theorem. So I can do 6 squared plus 4 squared is equal to what? Well, let's say just c squared. 6 squared is 4 squared equal to c squared. 36 plus 16 is 52 is equal to c squared. All right, so if I square root it and round it to 1/10 of an inch, what should I get? 7 point what? 2 inches. So 7.2 inches is the length of my diagonal. All right, last one, then we're done for today. One of the classic engineering uses of similarity. All right, so if you ever want to be an engineer, you'll probably see this. Is measuring of the width of a river, which is not easy to do with a tape measure. And engineers spot 2 points on opposite sides of a river, A and B. They measure the distance of BD along the river and then the length of DE perpendicular to the river as shown. They draw a line from A to E to mark the intersection of AE and BD at point C. So all of what they just said, they put here. All right. Now, we're going to explain why triangle ABC is similar to EDC. So remember, we can either do this by side, side, angle, or angle, angle. Which postulate makes the most sense to do? Be what? Angle, angle. All right, because we already know we got the 90-degree angle. All right, that's already one angle. What other angle do we know for a fact is congruent? The vertical angle right here. So since angle ABC is congruent to angle EDC and angle ACB is congruent to angle ECD, that means the triangle ABC is similar to triangle EDC. All right, so we just showed that those two triangles are similar. Now, since we know that they're similar, we can solve some problems with it. So, they said that BD is 225 feet. So this entire stretch right here is 225 feet. CD is 30 feet. And DE is 12 feet. And they want us to find the width of the river AB. So let's call that X. So first off, before we can even set up the proportion, what side do we need to find, given what information we're given? BC. All right. Why can we find BC right off the bat? Right, because we know the full length BD is 225, and a piece of it, which is CD, is 30. So how would I find BC? Subtract 30 from 225. And that'll give you BC, which is what? 195. Now I can set up my proportion. So what are my two corresponding sides? So let's start with BC. What's the corresponding side to BC? DC or CD, so that'll be 30. It'd be equal to what over what? What's the other proportion? 12 over X, or it's actually X over 12. Because we got to keep our triangle's consistent. All right. Now, so we're not dealing with big numbers. What could I do right here before I cross multiply? I could simplify it. So, little trick. If you do 195 divided by 30 in your calculator and then hit math and then enter twice, it'll simplify the fraction for you. So you do 195 divided by 30. Whatever you get, hit the math key and then enter twice. And the math key is right below the alpha key. Oh, it'll give you 13 over 2. It's equal to x over 12. Now we got nicer numbers to play with. So we do 13 times 12 is equal to 2x. So 2x is equal to, what's 13 times 12? 156 divided by 2. What's AB equal to? 78 feet. So this lesson is almost like a review of stuff that we've already done. Basically just with right triangles, there's really not much different from normal similar triangles. They're still just proportional. All right. Any questions on any of this? All right. So your homework for tonight is pages 3 and 4. All right. You guys got a solid 30 minutes, so you can probably knock that out now.